Hi everyone! Today we are starting proofs! Yay! Alright, so our objectives for today are that students will be able to use algebra to write two-column proofs and use properties of equality to write geometric proofs. Let's get started. So when are we ever going to use algebraic proofs? And today we're going to learn something called algebraic proofs, and here's one real-world example of them. So the Fahrenheit scale sets the freezing and boiling points of water at 32 degrees Fahrenheit and 212 degrees Fahrenheit respectively, while the Celsius scale sets them at 0 degrees and 100 degrees. You can see, you can use an algebraic proof to show that if these scales are related by this formula, by Celsius equals 5/9 times F minus 32, then they're also related by the formula Fahrenheit equals 9/5 Celsius plus 32, alright? And this probably won't make a lot of sense right now, but hopefully by the end of this lesson you'll see how we can do this. Alright, so before we jump into proofs, we need to learn about some properties of equality. Alright, so throughout the whole year we're going to be learning definitions, postulates, theorems, properties, and all of these are really important to learn, because you will be using them for the rest of the year every time you write a proof. So anytime we learn new properties, definitions, postulates, and theorems, keep those notes in a safe place and look back at them throughout the year because you will need to know them. As I've told you a million times before, geometry builds on itself. So we can't just forget about things that we learn in chapter 1 and 2 once we get to chapter 8, all right? We have to remember everything, all right? And I don't mean you have to, know everything like the back of your hand until June, although that would be ideal, all right? But you need to be familiar with all of these postulates, theorems, definitions, and properties for the rest of the year. All right, so first of all, let's start with addition, subtraction, multiplication, and division property of equality. So basically, the addition property of equality states that if A, oops, that was a horrible A, if A equals B, then we can say A plus C equals B plus C. So basically what we're doing is we're adding C to both sides. That is the addition property of equality. And hopefully you notice that these are in if-then form. These are called conditional statements. All right, so we're using those conditional statements in our properties of equality. Then subtraction property of equality. If A equals B, then A minus C equals B minus C. So basically we're subtracting C from both sides of the equation. Multiplication property of equality. If A equals B, then A times C equals B times C. We're multiplying C to both sides of the equation. And last but not least, the division property of equality. If A equals B, then A divided by C equals B divided by C. So if we divide C, if we do one side of the equation divided by C, we divide the other side of the equation by C as well. Division property of equality. All right, hopefully all of these are familiar, and you've probably been doing these with algebraic equations without even knowing it. All right, so when you add something to both sides of the equation, that's the addition property of equality. When you multiply something to both sides of the equation, that's the multiplication property of equality. And same thing with subtracting and dividing. All right, now the distributive property. So if A times B plus C, so if we have this expression right here, then A times B plus C equals A times B plus A times C. All right, we're just formally stating what is the distributive property. And then the substitution property. So if A equals B, then A may be replaced or substituted by B in any expression or equation. All right, so if A and B are the same value, we can substitute in B for A at any time. All right, so these last three might be a little bit new, or we just might have never given a name to them before. So let's go through them. Reflexive property. For any real number A always equals A. So a value will always equal itself. Reflexive, think like if you're looking at your reflection in the mirror. If A is looking at its reflection and the equal sign is the mirror, A will always equal A. A value will always equal itself. 5 will always equal 5. X will always equal X. This is the reflexive property of equality. All right, then symmetric property. If A equals B, then B equals A. So the symmetric property just states we can always switch them, all right, because if they're equivalent, A equals B, then B always equals A as well. So all we're doing is switching them. And then the transitive property. If A equals B and B equals C, then we can say that A equals C. So essentially what we're doing here is we're saying A equals B and C equals B. Both of them equal B. Therefore, we can say that A is equal to C. This is called the transitive property. All right, so when do we need to use the properties of equality? Well, properties of equality can be used to justify steps in solving an equation. And this is something new that we're learning today, a two-column proof. And we're going to be using these for a while. All right, so two-column proofs is a common format used to organize a proof. The left side of our proof is always our statements or our steps, okay? So we always put our statements on the left side. And the right side is always where we list the reasons, all right? Or what reason justifies each step. That's going to go on the right side. What can be used as reasons? Well, anytime we learn new properties, that can be used as a reason. So all the properties we just learned, all the properties of equality. Definitions can be used as reasons. Postulates can be used as reasons. And theorems can be used as reasons as well. So properties, definitions, postulates, and theorems all can be used as reasons on the right side of our two-column proof to justify every statement we make. All right, so I should have handed you out a handout titled Writing a Two-Column Geometry Proof. All right, what I want you to do is keep this handout in a very safe place because this will be your guide to solving proofs the rest of the year. And we will be doing proofs for the rest of the year. So follow these steps to help you solve proofs or to write two-column proofs. So the first step you want to take is copy all of the given information down. So even if it's something you think is obvious, all right, imagine you're explaining this to a kindergartner, to a 5-year-old. Even if you think it's obvious, it may not be obvious to somebody else. So you always have to state the given information. Then pause, take a moment to think about what you're reading and get an understanding of what you know and what you're trying to prove. So what is the given information? What do you know about this situation? And what are you trying to prove? What is your end goal? Make marks on your diagram to represent what you know and what you're trying to prove. All right? I've told you this before, but especially in geometry, a picture is worth 1,000 words. So look at your diagram, mark it up, pause, and take a minute to analyze what you know and what you're trying to prove. Then, write and work with the equations based on the given statements if possible. All right? So, take the equations or the statements you have and work with what you have. Sometimes you can convert these statements into equations using different definitions and properties, theorems, postulates. Then you're going to want to develop new equations from the diagram if possible. So you started with what you knew and you wrote new equations based on that. Then you looked at your diagram, all right, and wrote new equations from that. You're stating the obvious facts that you can get from your given information and from your diagram in order to get to your end goal. Then you want to manipulate and combine your equations, always keeping your goal in mind. So you always want to make statements and give reasons for things that will help you reach your end goal. If it doesn't help you reach your end goal, there's no point in writing it in your two-column proof. All right, and some common things we're going to use are the transitive property or substitution to help us combine two lines. All right, now this may seem a little bit overwhelming, all of these steps right now, and you're like, I haven't even seen a 2-column proof done yet. All right, so don't worry about it if it seems a little bit overwhelming, but if you, for instance, have a page protector at home or somewhere you can keep this handout and keep it safe for the rest of the year, trust me, it will help you. All right, so these are the steps I want you to take when solving a proof. All right, now we're going to move on and see a 2-column proof in action so you can get an idea of what I've been talking about for the last couple minutes. All right, so we've got our first example. We're going to be using the properties of equality to help us fill in this 2-column proof. So, first thing we want to do is analyze our given information and what we're trying to prove. We're given that 4x minus 1 equals 27, and we're trying to prove that x equals 7. So the first thing we want to do is state our given information, all right? This is our equation that was given to us, and our reason that we want to put on our reason side of our proof is just given. That is our given information, all right? Now our end goal is x plus 7, so that's always going to be our final step in our 2-column proof. And then they kind of gave you this step here, but they won't always give you that second step or the steps in between, okay? So first, we've got our given information, our reason is given. Then, in order to get from this step to this step, what did we have to do? All right. What we had to do to get from step 1 to step 2 was add 1 to both sides. All right. We added 1 to both sides, and that is just algebra, right? We want to get 4x by itself. So adding 1 to both sides gets the 4x by itself. All right. So we added something to both sides of the equation, so our reason for step number 2 would be the addition property of equality. All right, and I like to abbreviate property, and then of, and you can put an equal sign means of equality, okay? But you have to put of equality there. Then, how did we get from step 2 to step 3? How did we go from 4x equals 28 to x equals 7? What we did was divide by 4. We divided both sides by 4. So to get from step 2 to step 3, we divided both sides by the same number. Therefore, this would be the division property of equality, and that would be our reason how we got step 3, how we got x equals 7. So the division property of equality would be our reason for number 3. And you just solved your first proof. All right, number 3. So number 3, we're given that negative 9 times 2x minus 3 equals 63. We're given an algebraic equation. So automatically we write that down in step number 1, and our reason is that that is the given information. That is given to us. Our goal is to prove that x equals negative 2, so that's going to go at the end. And then they gave you the in-between steps, but they won't always do that, all right? And how we get these steps is just by doing inverse operations. It's just algebra, all right? So for now, we're just filling in the reasons. So what we want to do is ask ourselves, how did we go from step 1 to step 2? How did we go from this to this? What we did was we distributed the negative 9 to both terms inside the parentheses. So we did negative 9 times 2x, negative 9 times negative 3, and that got us negative 18x plus 27. So how we went from steps 1 to 2 would be our reason that would go in line number 2, and that would be the distributive property. So we put distributive property as our reason number 2. Then we want to ask ourselves, how did we go from step 2 to step 3? What did we do to line number 2 to get us to line number 3? If you said we subtracted 27 from both sides, you are correct. All right, so we subtracted 27 from both sides. So subtracting something from both sides of the equation would be the subtraction property of equality. So we say subtraction property of equality. Then, last but not least, we want to ask ourselves, how did we go from step 3 to step 4? What did we do to get x equals negative 2 when we had negative 18x equals 36? What we did was divide both sides by negative 18. Divide both sides by negative 18. So we divided something from both sides of the equation. Therefore, our reason for step 4, how we got line 4, was the division property of equality. All right, and you can abbreviate property like I said before, and you can use the equal sign for equality. I will accept that, but you need to write out everything else. All right, especially subtraction. You can't just put sub, all right, because I don't know if you're saying substitution or subtraction. So you have to write out that first word always, okay? But I'll allow you to abbreviate property and equality, put an equal sign, okay? If you have any questions on this, please raise your hand, call me over so I can help you. Otherwise, let's move on. All right, number 5. So number 5, we're given this equation right here. So copy that down in our statement number 1, and our reason number 1 is just that is our given information. Now our goal is to prove that x equals 2/3. So that's always going to be our final statement. And then we got to figure out everything in between. How did we get from here to here? So every line has to have a reason. So every time we do something algebraically, we have to explain it with a property or explain what we did with a reason. So starting with line number 1, how did we go from line number 1 to line number 2? How did we go from this statement to this statement? So if we're looking at what's different about this statement and this statement, we can see that we distributed the negative 7 to both terms here. We distributed the 6 to both terms inside the parentheses there. So therefore, to go from line 1 to line 2, we used the distributive property. All right, so we write out distributive property is our reason number 2. Then, how did we go from line 2 to line 3? If you're analyzing this and looking at what we did was we combined like terms. So we said negative 7x plus 4x gives us negative 3x. So our reason for this would just be we simplified, all right? So simplify. Or you can say combine like terms. I'll accept either of those, okay? Because that's what we did. We combine like terms. Sorry, that's really sloppy. Hopefully you can read that. Combine like terms. Now, how did we go from statement 3 to 4, 4 to 5, 5 to 6? So what I want you to do is pause your video right now and try to fill in reasons number 4, 5, and 6. When you come back, I'll have the answer written on your screen and we will go through it together. So I want you to try to find reasons 4, 5, and 6. Pause your video now. Alright, so you should have gotten these 3 reasons as 4, 5, and 6. So how did we get them? So to go from line 3 to 4, to go from statement number 3 to statement number 4, what we did is we subtracted 12x from both sides. Therefore, this is the subtraction property of equality because we're subtracting the same thing from both sides of the equation. Then to go from statement number 4 to statement number 5, what we're doing is we're adding 14 to both sides. Therefore, we're adding the same value. We're adding c to both sides. So if we look at our table of properties, that would be the addition property of equality. So how we got statement number 5 was because of the addition property of equality. So that's why that is our reason for statement number 5. Then last but not least, how did we go from 5 to 6? So how did we get x equals 2/3? We divided both sides by negative 15. Therefore, we're dividing both sides of the equation by the same value. So this would be the division property of equality. All right, if you have any questions, raise your hand, call me over so I can help you. Otherwise, let's move on. All right, so now we're moving on to algebraic proofs where all we're given is our given statement and our proved statement. So what are we given and what are we proving? Where before, I gave you all the statements and we just had to fill in the reasons. Now, you've got to come up with your statements as well. So, first thing we want to do is start by writing down our given information. So we are given, our first statement would be that we're given that 3x plus 1 equals negative 14. And our reason number 1 to go with this is that it's given information. Now, we know our end goal is to prove that x equals -5, so that's going to be our final line. Now, for step number 2, for statement number 2, what we want to do is we're thinking algebraically. So our goal here, we're thinking of our end goal. What we want to do is manipulate the equation so that we get x by itself. So what we would want to do is subtract 1 from both sides. So if we subtract 1 from both sides, we end up with 3x equals -15. And we subtracted 1 from both sides, so therefore this would be the subtraction property of equality. Alright, so remember what I did here, just to show you, is I subtracted 1 from both sides. That's how we got 3x equals -15. Okay, now our goal is to still get x by itself. So what we want to do is divide both sides by 3. So if we divide both sides by 3, we end up with x equals -5. All right? And what we did to get to statement number 3 was divide both sides by 3. All right? So this would be the division property of equality. All right? So reason number 3 is division property of equality. All right. Now together we just did this algebraic proof. All right. We went from our given statement and our given reason. All right. And we thought algebraically. We analyzed the situation. We kept our end goal in mind, was that we were trying to prove that x equals -5, and we solved this algebraically while giving a reason for every step. Alright, I want you guys to try number 3 on your own. Alright, so you're given an equation, you're trying to prove that m equals 33. You need to write out your statements and reasons. Alright, when you come back, I'll have the answer on your screen and we will go through it together. So go ahead and try this one. Pause your video now. Alright, so this is what your proof should have looked like. So starting out with statement number 1, we write out our given equation, and then our reason is that it's given. Then number 2, how we went from 1 to 2 here, our next step in solving this algebraic equation would be to subtract 10 from both sides. So we subtract 10, and we get that m divided by -3 equals -11. And what we did to get statement number 2 was subtract something from both sides of the equation, so our reason would be subtraction property of equality. The next step we would do to algebraically solve this equation would be to get m by itself. So here we did m divided by -3, so the inverse operation would be to multiply both sides by -3. So we multiply this side of the equation by -3 and multiply this side of the equation by -3. This -3 goes away, cancels out, and then on this side it equals 33 because -11 times -3 gives you positive 33. So m equals 33. That is what we were trying to prove, and how we went from statement number 2 to statement number 3 was multiplying both sides by -3. So this would be the multiplication property of equality. Alright, if you have any questions, call me over so I can help you. Otherwise, let's move on. Alright, so what I want you to do is, on the final side of your notes, you have this worksheet that says name that property. And what I want you to do is get some practice with identifying which property you're using. So you're going to match the statements with the properties of equalities, and just so you know, some properties will be used more than once. Alright, so I want you to try to do this all on your own. When you come back from unpausing your video, I'll have the answer written on your screen and we will go through it together. So go ahead and pause your video and try to do all of these, not just the odds, do 1 through 16, do all of them. Alright, so pause your video now. Alright, so here's the answers to 1 through 8. If you got all these right, no need to keep listening. But if you got some of them wrong, I'm going to explain how we got every single one. So if you want to listen to the explanation, keep listening. Otherwise, just fast forward ahead through the video so you can check numbers 9 through 16. Alright, so how did we get number 1? So number 1, if k equals 3, then 3 equals k. What we're doing is we're switching them around. So this is just like our example of if a equals b, b equals a. And this would be the symmetric property. Number 2, if 2x equals 14, then x equals 7. So how did we go from this to this? What we did is we divide both sides by 2, and that's how we get x equals 7. So we're dividing both sides by the same number. That would be the division property of equality. Number 3, 4 equals 4. We're saying a equals a. A value equals itself. This would be reflexive property. Imagine 4 is looking at itself in the mirror. It equals the same thing. It's looking at its reflection. Number 4, if negative 5x minus 1 equals negative 11, then negative 5x equals negative 10. How did we go from here to here? What we did is we added 1 to both sides of the equation. So because we're adding the same value to both sides of the equation, that would be addition property of equality. Number 5, if 10a equals 2b and 2b equals c, then 10a equals c. So if a equals b, b equals c, then a equals c. That's the idea here. 10a equals 2b and c equals 2b. Both of them equal 2b, therefore they equal each other. This is the transitive property. Number 6, how do we go from this to this? Well, we're distributing the negative 7 to both terms inside the parentheses. This would be the distributive property, E. Then number 7, if 6y equals 24, then 6y minus 3 equals 24 minus 3. What is changing from this equation to this equation? We're subtracting 3 from both sides of the equation. So if whatever we do to one side, we do to the other. Here we're subtracting the same number from both sides, so this is the subtraction property of equality. Alright, number 8. How do we go from 10x plus w equals 41, w equals 1, then how do we get to here? So what we're doing is we're saying if we know w equals 1, we can substitute 1 in for w, and that's how we get 10 plus w, 10 plus 1. Equals 41. So this would be the substitution property. Alright, so here's your answers for 9 through 16. Check your answers. If you got them all right, you're done. You don't need to keep listening. You can look to the board to see what to do next. Alright, if you did not get these right, keep listening and I will explain how we got each and every answer. Alright, so number 9. Y divided by 2 equals negative 10. Then y equals negative 20. So how did we go from here to here? What we did is we multiplied both sides by 2. So we multiplied this by 2, multiplied this by 2. That's how we got y by itself and y equals negative 20. So because we're multiplying both sides by the same number, this would be multiplication property of equality. Number 10, if 3x equals 2y and 2y equals z, then 3x equals z. If a equals b, b equals c, then a equals c. Both of them equal 2y, therefore they equal each other. Transitive property. 11. 7m equals 35, and then we're adding 4 to both sides of the equation. So because we're adding the same value to both sides of the equation, this is the addition property of equality. Number 12. If negative 2x equals 18, then 18 equals negative 2x. If a equals b, then b equals a. This is the symmetric property. We're just switching them. Number 13, we're given this expression and we're given that x equals 5. We're substituting 5 in for x. That's how we get this expression right here. So therefore, because we're substituting in a value for x, this would be the substitution property. 14, if m equals negative 2, then am equals negative 16. So how did we go from here to here? What we're doing is we're multiplying both sides of this equation by 8. That's how we went from this to this. So essentially it's a little backwards from what we're used to, but what I want you to recognize is how do we go from the first statement to the second statement. And what we're doing is we're multiplying both sides by 8. So this would be the multiplication property of equality because we're multiplying. 15, 10y equals 10y. A equals A. It equals itself, all right? It's the same value. So this would be reflexive property. And last but not least, 5x plus 8x equals x times 5 plus 8. So this is essentially reverse distributive property, all right? So what we're doing is we're factoring out an x. If we look at it, we're used to going from this to this, all right? But it is still distributive property. We're just showing it backwards. So 16 would be distributive property. All right, if you have any questions about properties of equality or algebraic proofs, please ask. Otherwise, look to the board to see what to do next, and I hope that you have a great day.